Do you want to improve your reliability in just a few minutes? The best way to get started is with smoke test. Smoke testing is a form of test automation that's very easy and quick to implement and dramatically improves your application deployment and reliability. Let's see how it works. So what is smoke testing? Imagine you're buying a house. Before picturing the decorations and where to put the furniture, wouldn't it be best to check the foundation of the house? If the foundation are in a real bad state, there is no point in looking at the paint. The house has bigger problem. This is exactly what smoke tests do. They check that nothing is fundamentally broken. The foundation is solid, the pipes aren't leaking, the electricity is not shorted out. Smoke tests have other names, so you might know them also as health checks or probes. But why are they called smoke tests? There are two possible origins for the term. From what I can tell, the most common origin is in electronics. You power your circuit board, and if smoke comes out, that's bad. Something is burning. The other origin I've seen is in plumbing. Apparently, you can use smoke or some colored substance to test for leaks in pipes. In any case, the idea is the same. A quick way to test if something's wrong. You can tell a smoke test by its four characteristics. First of all, smoke tests are a form of test automation, so they should run automatically even if it's a simple bash script. Smoke tests are easy to write. This is because they only test the essential parts in your code. For the same reason, they are very quick to run, making them a fantastic first step towards improving your app's reliability. You can even set them up in your continuous integration pipeline, which ensures that the app doesn't get deployed if something is broken. Here are all the places in which you can put smoke tests before committing the code, allowing developers to test locally in your continuous integration pipeline, before running long tests like end-to-end or acceptance tests. As I said, there's no point in checking the paint if the pipes are leaking. Then we can run smoke tests before deploying the application, whether on the staging environment or in the production environment. And after deploying the application, to check that the application has been successfully deployed. The most basic type of smoke test is what I call health checks. Here we test that the application is running and has started. For example, if we are working with a web application, we can get one of these pages and check for content. If the footer is there, chances are that the whole page is fine. Now, if we are working with some API, we can send a request to an endpoint. We know it will return an OK status if the application is started and running. There's no need to be fancy. We only need to return a string or a status code. Maybe some diagnostic data if that helps you decide about the health of the service. You can also use smoke tests to answer the question, is the server up? Is the database working? Just run a simple query and check that the database call finished without an exception. On more complex systems, like with microservice architecture, you can use smoke tests to check the multiple components that make your system. For example, using one or more tests per component or per service. We can take smoke test one step further and test whatever infrastructure these services depend on. So coming back to infrastructure, we can do smoke testing for infrastructure. This is another class of tests that check that the relying servers and services are ready for deployment. And here's where we really test the foundations of our system and detect basic configuration errors. For example, we can check that servers are online, we can ping network ports and check that firewalls are open, we can check DNS records, we can check SSL certificates. So how do we actually set up smoke tests? It can be as simple as writing a bash script for local testing or integrating smoke tests into your CI/CD pipeline. For example, you could set up a post-deployment smoke test to check that the database is connected before making your app live. One quick way to get started is with pre-commit hooks. These are executed before we run a git commit and will fail if the smoke test doesn't return a successful status code. Here I'm using a bash script and we'll start by starting the application. We are assuming this goes into the background, and then running a local script that will simply check that the application is online. If the status code is not zero, it's going to recheck the commit. And finally, we stop the application. Here's the bash script that will check the application is online. We're simply going to capture the return code of curl. We are pinging an endpoint in our application, and if the status is different than 200, we are going to print an error message and exit with 1, so the pre-commit hook fails. And this is all that it takes to simply run a smoke test locally in your application. As you can see, this is just 4 lines of code, and it will dramatically improve the reliability of your code because you have something that says the application has started and is running. The important part is that this is automated, so you don't have to remember to run this test before doing a commit in your repository. Now let's write an infrastructure test. We're going to use this test to check that the server name is what we expect, and this will also check that the server is reachable. So let's start first by trying to SSH into the server address and run hostname. This will return the hostname of the server. Here, 2 things can fail. Either the SSH doesn't connect, in which case it's going to fail because the server is not reachable. The other failure mode is that the hostname is not what we expect, meaning we are connected to the wrong machine. And we can make a simple string comparison to check that the remote server is what we expect. If that isn't what we expect, we're going to return an error message and exit with 1. We can also put that into our pre-commit hook, or we can run that into our CI/CD pipeline to check that the server is reachable and it is the correct server, so we don't deploy the application in the wrong environment. And here's yet another type of infrastructure test. We can test that the database our application depends is available and is connectable. And here we are going to simply pass some kind of password to connect, and this can be simply a monitoring password with few privileges on the database. And then run pg is ready to try to connect to the database, and this will automatically return a non-zero exit code if the connection is not ready, the server is down, or not reachable. If we put this into our CI/CD pipeline, we can detect that the database is not running and just stop the deployment before something else goes wrong. Now let's imagine we are having a e-commerce platform and we want to smoke test it a little better. What is the main things that a person running an e-commerce platform may care about? So let's do it with Python. We have the basics here. We are going to query the API endpoint. We are going to start with a dummy token that we'll use to log in with the API to authenticate. So the first test is simply checking that the home page loads, and here we are going simply to check the status code and some text in the response. Next, the login, we can try the authentication code and see what is the response, see that it has the properties we expect and that the status code is 200 as expected. We can see also the products in our application, and we don't need to be very thorough here, simply testing that the status code is correct and the structure of the JSON object makes sense. We can even test adding items into the cart, and here we also don't need to be very fancy. We only need to test that there is a response that is JSON and this has some essential properties. The same thing we can use to test that the cart has items, and as always, this doesn't need to be exhaustive or very fancy. We are only testing that the endpoint returns something that makes sense. At this point, we are only making sure that this path that we care most about makes sense. So the selection will depend a lot on your infrastructure, on your model, and how the system works. We are almost done, but before we go, I'll leave a few suggestions. First, check every vital path. Think about what are the worst and most obvious failures that I can test easily. Testing that the system or model is up and doesn't crash is enough at this stage. Second, run the smoke test periodically to monitor uptime and alert you on failures. You can use cron job or dedicated tools such as CloudProber to run your tests. Third, add a smoke test in your CI/CD. We already seen where you can put them. We can put them in your continuous integration pipeline before and after deployment. And you get bonus points if you use smoke test in combination with blue-green or canary deployments. This will allow you to decide to go ahead with the deployment or roll back if there is any problem very easily. And the smoke test is like the first test you are going to run after you start a blue-green deployment and before you switch the users from one system to the other. We have talked about blue-green deployments in past videos. I'm going to leave a link here on the screen so you can see them, and you can also see a video about canary deployments. Smoke tests work very well in combination with these two types of deployments. If you don't have any automated test, this is where you should start. Keep it simple, keep it fast, and save yourself a ton of headaches down the road. If you found this video useful, hit that like button, subscribe, and let me know in the comments if you're planning to implement smoke test in your workflow. Thank you for watching, and see you on the next one.